Okay, in this video, I want to show you how to simplify radicals. So I like to show you my way, and I'd like to ask you to use my way unless you have another way that works perfectly for you. So this is what we're going to do. We're going to do our little tree. So the tree lets us divide everything by 2. Okay, so I'm going to get down to 49, and 49 is 7 by 7. Okay, so now all the ends of your tree I've highlighted. And I'm going to get my radical going again, and I'm going to put all the numbers I just highlighted under my radical. When I do that, I'm going to then find doubles. I circle my doubles. Every double comes out as a single. Every double comes out as a single. So I am left with 2 times 7 outside and nothing inside. 2 times 7 is 14, and that tells me that 196 was a perfect square. Okay, so my answer, when I simplify radical 196, is 14. Okay, let's go on to 24. When I take the square root of 24, using the same method, it's an even number, I'm going to divide by 2. I can divide this by 2. And I can divide this by 2. All the ends of my factors, all the ends of those little trees, I highlighted. And then the highlighted ones, I'm going to put under the radical symbol. Those that are underneath are called prime factors. And if I multiply these together, 2 times 2 times 3 times 2, I will get 24. So now I'm going to simplify it by circling all the pairs. There's only one pair, it comes out as a single. Whatever's left inside gets multiplied and stays inside. So 2 root 6, or 2 radical 6, is going to be my answer. That's my simplification of radical 24. Okay, let's continue. When you get to radical 108 and you divide by 2, that's going to be 2 times 54. Divide 54 by 2, and you're going to get what? 2 times 27. And then 27, I can't divide by 2, but I do know it's 3 times 9. And then 9 is 3 times 3. Okay, so I'm going to highlight the ends. Those are my prime factors. Underneath my radical, I'm going to put 2 times 2 times 3 times 3 times 3. Now, I could check this, multiply it all together, and I should have 108. It is a good idea to check that to make sure that you've done this correctly. So let's see. We have 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And 27 times 4 is indeed 108, so I know I'm good. Okay, circle your pairs. Here's a pair of 2s. That comes out as a single. Here's a pair of 3s. That comes out as a single. And I end up having 6 radical 3 for my simplification. Okay, so whatever stayed under the radical was under the radical again. Okay, so that's where that came from. Where did the 6 come from? The 2 numbers that came out, I multiplied together, and that is where the 6 came from. All right, let's do 216 as well. So I'm going to always divide by 2 if it's even. You may change that up, but it's a sure bet way to get the answer to your problem. So I'm going to keep doing it this way just to be consistent with an instructional skill. So here's 2 times 27, and then we have 9 times 3, and the 9 is 3 times 3. Okay, find all your ends. So be careful because I've got one hiding over here. Those are all my ends. I'm going to take a radical now, and I'm going to put 2 times 2 times 2 times 3 times 3 times 3. Okay, so that's going to be 2 times 2 is 4, 4 times 2 is 8, and 8 times 27 will get me to 16, so I know I have all the numbers. Okay, so circle your pairs. Remember, they come out as individuals. And what's left inside is another 2 times 3. So I have 2 times 3 outside. I have 2 times 3 inside. So that gives me 6 radical 3. Okay, a couple more. So let's go down to 128. This is also even. So that's 2 times 64. And that is 2 times 32. And that is 2 times 16. Which is 2 times 8, which is 2 times 4, which is 2 times 2. Okay, so I've got quite a long list here. So let's not miss any. Okay, there they all are. Get your radical and put it all under. So 1, 2, 3, 4, 5, 6, 7 twos. 2, 1, 2, 3, 4, 5, 6, 7. Okay, here's a pair that's going to come out as a single. Here's a pair, comes out as a single. Here's a pair, comes out as a single. So I have 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, and I have 8 root 2 for an answer. Okay, so let's keep moving on. We've got still more to play with here. Okay, so 100. Now, what if you saw 100 and said, you know what, I know 100 is 10 times 10. Oh, that's a double. So even though this is not the prime factorization, could I put 10 times 10 under? And then follow the same rule. There's a pair. It comes out as a 10. Nothing's left inside. My simplification of radical 100 is a 10. So radical 100 is a perfect square because there's nothing left under the radical. Okay, we had a perfect square above here too when I got 14. So why don't I also indicate that 14 is a perfect square, just to introduce some terminology. All right, sliding down. 150. So 150 is going to be, well, looking at that, is there a way to do it that's not by 10 that might get me there quicker? So let's try something a little different. Now, if you're comfortable just dividing by 2, totally fine. Keep doing that. But look what this gives me. Kind of gives me the answer a little bit quicker. Okay, so I'm still down to my prime factors. I have 4 of them. Under the radical, I'm going to put 5 times 3 times 5 times 2. Here's a pair right here. Pairs come out as singles, and you're left with 5 root 6 for the simplification of 150. So 150 was not a perfect square. Okay, one last one. Let's finish strong. 98. Okay, so 2 goes into 98 49 times. 49 is a perfect square. So 7 times 7 gives me 49. Here are all my ends. They go under a radical. And my pairs come out. 7 root 2. And we're done. Okay? So there was a video up here. I'm going to replace this video with my video. Okay, because I think this is a good method for having you always get to a simplification without really any stress or strain or any confusion, I hope. So I hope you found this helpful. Thank you so much for listening.